Welcome to homework.
According to energy conservation law, the electrical energy that was produced in this question should be equal to the heat that was generated in this question. So we have U is equal to Q. And we know electrical energy can be equal to power times time, and the amount of heat can be equal to MW/CW delta T plus MAL/CAL delta T. MW here is the mass of water, CW is the specific heat for the water, delta T is the changing temperature. And when MAL is the mass of the aluminum cup, and CAL here is the specific heat of the alumina. So we also know that the electrical power can be equal to I squared R. I is the current, R is the resistance. So we have I squared RT is equal to MW/CW delta T plus MAL/CAL delta T. And we also know that the current can be equal to the total voltage divided by the total resistance. So capital R here is the resistance of the heating element. And R here, the lowercase r here is the internal resistance of the battery. So if we use V over R plus R, substitute for I, we'll have such equation here. And then we can do some arrangement here. Eventually, we'll have the time is equal to delta T MW/CW plus MAL/CAL over capital R times V over R plus R to the power 2. So we know the mass of water is given as 0.2 kilograms. Specific heat for the water is 4186 joule per kilogram times degree Celsius. The mass of the aluminum cup is 0.13 kilograms. And the specific heat of the aluminum cup is 900 joule per kilogram times degree Celsius. The changing temperature in this question is 13.3 degrees Celsius, since the temperature is rising from 21.2 degrees Celsius to 34.5 degrees Celsius. And we know the total resistance should be equal to 29.2 omega. And the potential is given as 96 volts. And the resistance of the heating elements is 28 omega. So now let's plug in back to the equation to determine the time, which is equal to 13.3 degrees Celsius multiplied by 0.20 kilograms times 4186 joule per kilogram times degree Celsius plus 0.130 kilograms times 900 joule per kilogram times degree Celsius over capital R, which is 28.0 omega multiplied by 96.0 volts over 29.2 omega to the power 2. And this will give us the time is equal to 42 seconds. And this is the answer for this question.